Welcome to another exciting physics video brought to you by Vision Concept Academy. We'll be looking at work, energy, and power. At this point, if you are new to this channel and you're yet to subscribe, kindly subscribe to our channel to get wonderful, exciting videos for you. Whether you are doing JAMB or WAEC or NECO or GCE, or you're just studying physics, this video is for you. And today we'll be looking at work. What is work? Work is said to be done when a force moves an object in a distance in the direction of the applied force. Okay, so work is said to be done when a force moves an object in a distance along the direction of the applied force. So if, for instance, this is an object, it's a body, an object at rest. So the body or the object is at point A, and there is a point along this line known as point B. So if a force is applied on this body, force F measured in Newton, if it's applied on this body, push, and you see where my hand is going, that's the direction of the force. Until this body begins to move, work is not done yet. If you like, apply all the force and this body is still at rest. The work on this body is zero. Until this force is big enough to move this body along this distance, that is, along this path. If the body moves away, as the force is applied, the body moves opposite direction. It's not force, it's not work. It's not work. It is when the body moves along the direction of the force is going this way, the body must move this way for work to be done. So if the body moves along this direction, it will cover a distance, D, measured in meters. So work done mathematically is equals to force times distance, where force is in Newton, distance is in meter. The unit of force is in joules. It's in newtons. Sorry, it's in joules. It's in joules. Force is in joules. All right. Unit of force is in joules. All right. So work done in a force field. You know, when you are lifting a body of weights, understand? The force of the body being lifted, you understand, is defined as the force of attraction on the body due to the earth. So if you have the earth, this is the earth, for instance, you know, we say that any body that's attracted to the earth like this is experiencing with force of attraction, and that force is given as weight is equals to mass times acceleration due to gravity. So that's the force. That's the force that's attracting this body to the earth. You understand? So there's a field force on the earth that moves this body towards it. So most of the time, the work done to bring this body to where the earth is mgh, where h is the height, where the body is and where the earth is. That's the weight, that's the force, that's the work done to bring the body to the earth. mgh. That mgh is what we call the gravitational potential. The gravitational potential. We'll look at potential energy later. Gravitational potential, that's the work done to bring the body to the earth, you know, in the force field. So mg, m is mass, g is gravity, and h is the distance. So in that case, when the body falls freely in a force, when the body falls freely in the force field, the force of the field does work on the body. So hence, the body falling freely under gravity Understand? The Earth's gravitational force does work on the body. So there is a component of the Earth doing work on the body. So we have another term known as energy. What is energy? What is energy? Well, define force as work as the force that is applied on the body and will cause that body to move in the direction of the force applied. So energy is defined as the capacity to do work. Energy is defined as the capacity or ability to do work. Energy is defined as the capacity or ability to do work. So anything that has a capacity of doing work has energy. Anything at all, understand? A person pushing a car, along the road, understand, is doing work on that car. The person that is said to possess that energy, the person is said to possess the energy which he exerts to make the car to move. So there's something that, we have defined work as that thing that makes the body to move, understand, along, that the force is applied on the body. When it moves, work is done. But that thing that is pushing that thing, that applying that force, that thing has the capacity to do work. If that thing cannot move this thing, work is not done. So there is inherent ability or capacity on a body to cause another body to move a distance. So energy is doing work, and work is applying force over a distance. Energy is doing work. See the relationship? Energy is doing work, but work is the force applied over a body, on a body over a distance. Okay. So energy has different forms. You understand? So like I said before, a person pushing the car along the road has energy. You understand? Because the energy inside that person is translated to the work. So work and energy are measured in the same thing, joules. So they are both applied on a body to move, to make it move. But energy is ability to do work. So energies are different types. What are the types of energy? Types. I will just talk about the types briefly. I have number one, mechanical energy. We'll see that in details in this course. Mechanical energy. I have number two, I have heat or thermal energy. That's another form of energy. Number three, I have light energy. Number four, I have chemical energy. Number five, I have electrical energy. Number six, I have atomic energy. And number seven, I have solar energy. So these kind of energies are not inexhaustive, but you see, these are the types that we consider under mechanics and physics. We'll be looking at mechanical energy first. Under heat, we'll see this one. Under optics, we'll see this one, and so on. Electricity, we'll see electrical energy. Advanced physics, we'll see atomic energy. So mechanical energy basically are of two types. You have the potential and the kinetic energy. Mechanical energy are of two types. You have the potential energy and the kinetic energy. Okay, but the potential energy, number one, potential energy. and number 2, kinetic energy. What are these? They are the types of mechanical energy. Mechanical energy. Okay, so the potential energy is the energy that the body has because it is at rest. That is, there's a potential for that body to expend that energy. So if I have a body that is suspended up like this, and maybe something is still holding it, let's say something is holding it, so but there's a distance where it can expend that energy. You know, we said that energy is expended on work. So this body at a height has potential energy. Potential energy. And the formula for it is mgh, mass, gravity, height. Mass times gravity times height. That's the formula. Once this body is released from where it is, this potential energy is released. So if you calculate the mass times gravity that brings that body down, and times the height is going to cover everything in joules. By the time it hits the ground, you will see that that calculation, what you have, the value of energy that is going to be expended, that's what is going to be on the ground. So, but at the point where it was at rest, it was not doing anything at all. It was at rest. So note that word, the energy at rest. At rest. In the potential, that energy it has when it was at rest. By the time you release from rest, it changes to kinetic energy because it begins to move. You know, kinetic energy is when the body is at motion. At motion. At this point, kinetic energy is when the body is somewhere here and it's moving. It's moving. It's moving to hit the ground. So at this point, the body is at the state exhibiting kinetic energy, energy in motion. And the formula is half mv squared. Half mv squared, where m is still mass and v is the velocity. So we're going to quickly do 1 or 2 examples, put some practical into the kinds of energy before we move into power. So I'll just write an example on the board. It says that we should find the potential energy. Find the potential energy of a body of mass 10 kg standing on a building. You see, what is it doing? Is standing. Standing means it's at rest. On a building floor 10 meters above the ground level. Above the ground level. So it says potential energy. So they gave you mass, they gave you distance, height. So you know our G is 10 meters per second square. So that's acceleration due to gravity. So potential energy, PE, potential energy, is equals to mgh, where m is the mass is given as 10 kg, gravity is 10, and meter height. So this is 1000 watts joules. That's the energy. That's the energy it's extended. 1000 joules. 1000 joules. So just a matter of identifying that the body is at rest. This is the mass. Is the distance of the building to the, where the body is suspended to the floor of the building is 10 meters. That's the distance, and the acceleration due to gravity is 10 meters per second. All right. So we're going to quickly do example 2, still on this potential and kinetic energy. The next one we highlight kinetic energy. It says an object of mass 5 kg is moving at a constant velocity of 15 meters per second square. Calculate its kinetic energy. Calculate its kinetic energy. So kinetic energy KE is equals to half mv squared. Kinetic energy KE is equals to half mv squared. We are given that the mass of the body is 5 kg and that it is moving at a constant velocity of 15 meters per second. So everything is given there now. So we just go as KE is equals to half times 5 times 15 times 15. So when we do the maths, compute everything together, we'll find out that the work energy is 562.5 joules. So this is the energy extended by that body. Okay, so we have looked at work and energy, the difference between work and energy. What is power? Power is now the rate of work done. Power is now the rate of work done. Okay, so you see how they are related. Power is talking about time. Time, how fast? How fast? Power is the rate of work done. So I'm moving from force to work done to power. So this one is rate. Power P. Power P is equal to what? Work done over time taken. So you see, let me start again. A body is at rest like this. A force is applied. A force F is applied. If this body does not move, work is not done. It must move in a distance, and the condition of movement is that it must move along where the force is being applied. So I'm applying the force here, the body must still move here and cover a distance. Understand? So that's distance covered, and the force, S is distance covered, and this force is known as work. Now, who is the person that is doing the work? The person or the body doing this work is the one that has energy, because the energy is the ability to do work. Now, everybody that has energy to do work can do work, but how do we measure how fast the person is doing it? So that means if I have this body doing this work and another body doing another work here, still moving the same kind of distance, you understand? What we are now measuring as power is how fast is these two persons or two bodies doing this thing. If this is the same mass, the same capacity, the same mass, let's say this is the same, this is a person, they have the same mass, understand? They are moving the same mass over this thing. But this guy, let's call this guy A and guy B. Guy A is slower than guy B, and guy B is slower than. So if guy B approaches, let's say they have a destination they need to reach. Let's call the destination C. C is the same place, and maybe this point to point C is 5 meters, and this point to point C is also 5 meters. If B pushes this thing faster and gets to this place in 2 seconds, in 10 seconds, and guy A gets to this place in 20 seconds, which of them is doing has more power? based on this definition, guy B has more power because guy B has a faster rate of doing the work, because power is expressed as rate of work done. Faster rate, that means he expended more power. If this time taken is smaller, P will be greater. If this time taken is bigger, P will be smaller. So the person that does the work faster is the person that has the greater power. Power is work over time, and you know that work, by formula, mathematically, work is what? Force times distance over time. So if you have these parameters in your question, you are good to go. If you have these parameters in your question, you are good to go. Force times distance over time. But mind you, from our initial studies, we saw that S over T is what? Velocity. So work done too is, power is also force times velocity. I think I replace this one with velocity. So sometimes they can give you work done already and time taken, you can get power. They can give you force and distance and time, you can get power. Or they can give you force and velocity, you can get power. So no matter what they give you, you get power. And power is measured in what? In watts. In watts. In watts. Watt is W-A-T-T-S. So this is the unit of measurement of power, which is watts. So other unit of power, other units. Okay, before we go to other units, what is 1 watt? 1 watt is equals to 1 joule per second. 1 joule per second. Sometimes you hear these questions in the exam. You just be wondering where they are coming from. 1 watt. 1 watt, so 1 joule per second. 1 watt, 1 power, 1 watt power is equals to 1 joule. Joule is work done per second, time taken. So like I said, other units are 1 kilowatt. So 1000 watts make 1 kilowatt. And that is in terms of standard form, like this, the same thing. And 1 million watts make 1 megawatt. Or you can say 10 to the power 6 watts make 1 megawatt. Megawatts, not megavolts. Megawatts. Then there's another concept here known as horsepower. 1 HP is horsepower. Is equals to 746 watts. So know all these conversions very well. So 1 kilowatt hour is the work done in 1 hour by an agent working at constant rate of 1 kilowatt. So I will take one example or 2 examples of power, and then we would wrap up the video. Okay, so example, let's take an example here quickly. An example. So if at this point you're not subscribed to our channel, please subscribe so that you can get more exciting educational videos from Up Kitchen Concept Academy. So it says a car is moving at a constant speed of 20 meters per second. The force retarding its motion is what? Is given as 500 Newton. You now say calculate the engine. Calculate the engine power of the car required, okay, that's required to maintain the motion. Okay, so calculate so this force is retarding his motion. So for this car to keep moving, it has to overcome this force. I mean, this force has to be added to make that thing move. So that thing there really telling us that the force is moving with this. You have to overcome this. You have to have this force to overcome this one, so you can still continue to move. So we are just giving two parameters there. We are giving force and velocity. I told you that power can also be expressed in terms of force and velocity. So power is equals to force times V. Force times V. Because V is equal to distance per time. And what's the force there? The force is 500 Newton. 500 times velocity, which is 20. So by the time you do the math, I have 1,000. Yes, I'm correct. No, 10,000. 10,000 watts. 10,000 watts or 10 kilowatts. Now to convert to, because sometimes you will see options. If it is a option-based exams, you will not see it as this one. You see it as kilowatts. You are getting your answer as 10,000. You not see 10,000 kilowatts there. You will see 10 kilowatts. Convert to kilowatts. Okay, so that's it. So another example quickly. Example for call it quit this video. Like I said, please subscribe to get more content, more educational content. Yes, I'll call it. All right. So number 2, it says a boy of mass 10 kg climbs up 10 steps each of height 0.2 meter in 20 seconds. Calculate the power of the boy. The power of the boy. We need to calculate the power of the boy. So a boy of mass 10 kg climbs up 10 steps, each of 0.2. So in 0.2 meters in 20 seconds. So I'm not going to draw all the 10 steps, but I want to just show you something. If each of these steps is measured as 0.2, this one to 0.2, this one to 0.2, this one to 0.2, until you get to the 10th one. You understand? So the height will be the summation, or because we're not looking at this in isolation, we're looking at the height of this. They want us to get the height of this height. You understand? To get the height. So we're going to sum up this. The set is 10. So 10 steps. So we're going to sum it times 10. So the total height is 0.2 times 10, which is 2 meters. So the height is 2 meters. So the boy's mass is this, the height covered is this, the time went to is this. So find the power. So what formula are we going to use for this one? We're going to be using work done over time. And the boy power is equals to work over time taken. Work done. So what's the work done? Work is force and distance. The boy's force is mass times gravity, that's his force, then times the distance, which is h, then over time. So this is what we are going to be using. You see how they are intertwined. So mass is what? 10 times gravity is 10 again, times the total height is 2 meters. How do we get 2 meters? We said 0.2 times 10 steps all over time. Time is what? Time is what? 20 seconds. 20 seconds. So we're going to complete the math. 10 times 10 times 2 times 20. The final answer here is 10 watts. That's the power the boy extended. The boy extended. Remember, power is the rate of work done. So it is how fast work is deployed. That is power. Power is how fast work is deployed. And work is the force that is applied over an object to move in a distance in a direction of that force. So energy is the ability to do that work, because energy is uh, measured in terms of the capacity of the body to push anything, to make anything to move. You understand? That's energy. And we said that energy can be mechanical, can be electrical, can be chemical, all, but we are considering mechanical at this point, where we have two types: the potential energy and the kinetic energy. We said the potential energy is energy of a body that is at rest. The potential that body has when it's at rest, if it's released, it will release that potential, it will release that energy to do work. While the kinetic energy is the energy that possesses the body that's already in motion. Already in motion. Formula for kinetic energy is half mv squared, and the formula for kinetic potential energy is mgh, where m is the mass, g is the gravity or acceleration due to gravity, h is the distance, v is velocity. And we said that force is measured in newtons, work and energy is measured in joules, while power is measured in watts. I hope this lesson has been informative for you. I'd like to thank you for viewing.